Alright, so in this video we're going to be going over point slope form of a function. So we'll just go ahead and give that to you right here. So that's going to be y minus y1 equals m times the quantity x minus x1, where of course we know m equals our slope, and this function is going to pass through the point x1, y1. All right, so for example, if we had an equation that looked like y minus 3 equals 2x minus 1, we're going to have a function that has a slope of 2, and it passes through the point 1, 3. All right, so if you wanted to graph that, you would start at your point, so 1, 2, 3, and then you'd use your slope to find the next point. So this is rise over run. So we're going to go up to right 1. So 1, 2, and over 1. Plot that point. And we'll have an equation that looks like that. Now, if you were given a graph, let's say, let's go 1, 2, 3, 1, and 1, 2, 1. So you're given that plot right there, and we know these 2 points. So we know that this point here is -1, -2, and then this point here is 3, 1. And you need to write an equation for this function. You're going to go ahead and figure out, you're going to use one of these points as your point. It doesn't matter which point. And then you just need to figure out your slope. So again, that equals rise over run. So you can just count this out. So you're going to go up 1, 2, 3, and to the right 1, 2, 3, 4. So m is going to be equal to 3/4. So we know that our point slope form is going to be y minus y1 equals m times x minus x1. And then you can just go ahead and start plugging stuff into this equation. So I'm going to go ahead and use this first point for now. So we're going to go y minus, our y value is a -2, equals m, which was 3/4, x minus x1, which is a -1. So we're going to get y plus 2 equals 3/4 x plus 1. And then you can just simplify this by isolating y. So we're just going to go ahead and distribute this 3/4 out. And then subtract 2 from both sides. So we're going to get y equals 3/4 x. And I know that 2 is actually 8/4. So that's going to end up being a -5/4. So that would be your equation right there. Now, if you wanted to use the other point, you can go ahead and do that as well. So y minus 1 equals 3/4 x minus 3. So y minus 1 equals 3/4 x minus 9/4, add 1 to both sides, which 1 is really 4/4. So we're going to get y equals 3/4 x minus 5/4. Oops, fourths. Right, so these end up being the same thing, so it doesn't matter which point you use. All right, so that's how you would come up with the equation of this function if you're given 2 points on a graph. Now, if you aren't given the graph and you're just straight up given these 2 points, you don't actually have to graph it to count off what your slope is going to be, because your slope is going to be your change in y over your change in x. So you're just going to take these and add them together, but you're going to take the absolute value of each one and add them together. So you're going to have 2 plus 1 over this plus this. But again, it's the absolute value of this plus the absolute value of that. So 1 plus 3. So you're going to end up with 3/4 like we had up here. Now, if you're going to do it this way and you don't know if your slope is positive or negative, if you can't visualize in your mind that -1, 2 is over here and 3, 1 is over here, so your slope's going to be positive, the best thing to do is when you're doing your math over here, just stay consistent. So do this one. So name this ordered pair is your first one, and this one is your second one. So this is going to end up being equal to, so your delta y over delta x is going to equal to y1 minus y2 over x1 minus x2. And again, just make sure you stay consistent. So if you have your ones first, keep them that, and your 2 second, keep it that way on the bottom. All right, so here you'd end up with -2 minus 1 over -1 minus 3. So you'd end up with add a negative, you'd end up with -3 over -4. So 2 negatives equal a positive, so you'd end up with a positive 3/4, which is the same thing you got there. Now again, you could come over and do y2 minus y1, x2 minus x1. Again, just make sure you're consistent on your top and bottom. So you have 2 first on the top, make sure 2 comes first on the bottom, but it'll get you the same thing. So you'll end up with 1 minus a -2 over 3 minus a -1, which is going to be 3 over 4, right? So you get the same thing no matter which method you choose. Just stay consistent so you don't get confused. But whatever is easiest and makes most sense for you, go ahead and just use that. Now, another thing you might be asked when talking about point slope form is you're going to be asked for coming up with a function of a line that is parallel or perpendicular to some other line. Now, parallel means that they have the same slope. They're never going to intersect. So, parallel lines have the same slope. All right. Now, perpendicular lines, when they intersect, they form a 90-degree angle. All right. And their slopes are opposite reciprocals. So what that means is if you had, we'll go ahead and do a parallel line first. So say you want to find a line parallel to y equals 2x plus 1 and passes through the point 0, 4. You're going to go ahead and use this point slope form to help you out because we know that a line parallel is going to have the same slope. So for our new line, we know that m is going to be equal to 2, and we have this point here. So we can go ahead and just do our y minus 4 equals 2x minus 0. So y minus 4 equals 2x, y equals 2x plus 4. And that would be our line that is parallel to this line, but also passes through this point here. And you could graph that out and you could show that visually as well. So we can actually do that over here really fast, just so you can see it visually. All right, so for this first line that we're given here, we'll go ahead and let's do this in black. All right, we're gonna plot this one here in green. All right, so we got our y-intercept of +1 and then a slope of 2x. So we're gonna go 1, 2, 1, 2, 1. So that's our given line, and we were asked to find a line that is parallel to that, but also passes through this point here. So we're going to go ahead and graph this one in blue. So we've got a y-intercept of 4, 1, 2, 3, 4, and then a slope of 2. So as you can see, if I could draw to scale, if I could draw straight lines, you would see that these are parallel. So they've got the same slope. And this line also passes through 0, 4, which was actually our y-intercept. So there's that. Now, if we wanted to do lines that were perpendicular to each other, so let's do the same thing, except now we want to know perpendicular. So perpendicular, again, have slopes that are opposite reciprocals. So for a perpendicular line, so m perpendicular is going to be equal to opposite reciprocal of 2. So opposite is going to mean that you add a negative sign to it, and then the reciprocal means you flip the fraction. So this here we've got 2 over 1. So to become a reciprocal, we're going to do 1 over 2. And then again, we've got this point as well. So y minus 4 equals -1/2 x plus 0. And so then we just solve that out. Y minus 4 equals -1/2. Y equals -1/2 x plus 4. Now if we go ahead and we graph these, all right, and maybe I'll graph it more to scale this time. Again, green, I'll do this first one. So we're going to have a +1, is our y-intercept, and then 2x is our slope. So 1, 2, to the right 1. That's going to be our original line. And then we needed a line that was perpendicular. And so we found this equation here, and I'll graph that in blue. So we're going to have 1, 2, 3, 4. And then -1/2 is our slope. So we're going to go down 1 over 1, 2. So this is going to be our second line. And then we draw that out by connecting those dots, and we see here that it formed a 90-degree angle. So that worked out. So that's just a quick intro to point slope form. If you have any questions, let me know.